I'm Art Cornell, and I'm the amateur astronomer here uh, at the Osterville Village Library. In my previous life, I was a mathematical engineer. But now I've gotten into astronomy, and here I have a map, I guess you'd call it, of the solar system. And I've drawn this solar system out here. I have the sun right in the middle here. Oh, I can show you with this. There's the sun, and right there is Mercury and Venus, and there's the Earth, Mars, Jupiter, and Saturn. And of course, there is Uranus, which is out about 3 foot, would be about 3 foot out here. And Neptune would be out here about 5 foot. I can't draw those, so I just have these drawn. And it's all drawn to scale. The distances here are all pretty much drawn to scale, and all of the planets are somewhat in the same plane like this. And they all go around in this direction. They all rotate around like that. And the Earth now, right here, this is June 21st. This is the first day of summer. September 21st, the first day of autumn. First day of December, December 21st. March 21st. This is the first day of spring. And of course the Earth goes around here once a year. And I said that this is drawn to scale, so that it turns out that the distance from Earth to the sun is 92 million miles. Now, it's hard to imagine what 92 million miles is, but the circumference around here is, of course, 2 pi r, and r is 92 million miles, and 2 pi times that, it turns out to be, I have a little note here, 584 million miles that the Earth travels around the sun, and it does this in 1 year, 365 and a fourth days. Now, if you talk about per day, how far does it travel per day? You divide that 93 million by 365 and a fourth, and you come out with 1.6 million miles every day that the Earth moves. We are moving. Okay, and if you talk about miles per hour, it turns out to be 66,600 miles per hour. That's about a little bit more than 10 times what an airplane travels at. And we're doing that every day. It is amazing. We don't even know we're moving at that speed. It is like being in an airplane. You're in an airplane and the airplane is going 600 miles an hour. You're sitting there. You don't know that you're even moving unless you look out the window and see that it's moving. It's the same way here on the earth. The earth is moving around the sun and we're with it. We are moving with the earth. So, what I wanted to say is that in June 21st, right here, first day of summer, the Earth, if you can imagine now. Oh, by the way, another thing that I wanted to mention is that I've drawn this to scale the size, but not the size of the sun and the planets. Now, what I've done is I have a common pin here. Do you see the head on the pin here? See? Now, that is about the size of the sun. Okay, and that tip of that common pin. Now, the Earth, let me jab this in there. Did you see that? That's about the size of the Earth, where I just dabbed it in there. Can you see that? No, you can't see that. You can't see it because it's too small for this. It is amazing that if you can imagine now, this Earth, it's shaped like this, and it's tilted like this. And on June the 1st, can you imagine this being down in that little point there? All right? It's just we're just a speck down in there. But here is the Earth, and this direction is north. All right? And on June the 1st, the Earth is tipped this way so that the northern hemisphere now is towards the sun. Here's the sun. We're right here. The sun is coming in at this angle on the northern hemisphere, and we are, of course, right here on Cape Cod, and each day, of course, we spin around like this and come back that's once a day, and that's what happens. Okay, now as the Earth moves around this way, it always is oriented this way. When it's in December, it's this way, so that then the southern hemisphere is warmer because the sun is coming in from this direction. And of course, over in March, it's like this. So as it goes around, it is always in that orientation. Now, what is what is interesting to me is on right around in the begin, here's June 21st. This would be in early July, right here, and last summer, the planets at that time. See how this is red, and notice that Mercury is right here, and Venus is right here, Mars is right here, and Jupiter is there, and Saturn is right there. So, if you can imagine now, here is Cape Cod, and here is the sun, okay, and it's noontime. Okay, as time goes on during the day, now there's sunset, and the planets are over here. But as we come around like this, it isn't long, and we can look out and we can see Saturn. And then it comes around, and we can start to see Jupiter. And then we come around and we see Mars right here, and then Venus, and before the sun comes up, we can see we can see Mercury. So last summer, I woke up at 4 o'clock in the morning, and I got in my car and I drove down to the beach, and I look up, and there is Venus, Mars, Jupiter, Saturn, four of them. Mercury, it turned out there is some clouds around, so I wasn't able to see it. But I saw 4 at about 4:30 in the morning, just before the sun came up in early July. That I saw 4 planets all at just one look. It was absolute, and it was possible to see 5 of them if you ever could see could also see Mercury. So now it turns out that now it is October the 14th. Okay, now instead of being here, we are a little bit past September the 21st. We're right about here, and of course we are like that. Now, if you can, the sun is off this way now. See? We're here, and the sun is off this way, and if we are here at noontime, right here, the sun is right at noon. Now, as the day goes on, we start. Remember, the sun is out this way now. And we come around this way, pretty soon the sun sets. Okay? And we now are able to see as we come around, we can see Saturn. We can see Jupiter over here. And if you, well, Jupiter is right there, right now. See, the orange ones, let me put this over here. The orange ones are where the planets are now. So the Earth is right here, and if you look up now, you can see Jupiter is, Saturn is over this way, and Jupiter is over this way, and this one isn't. You have to wait a few hours later to be able to see this one, which is Mars. And the Mercury and Venus are behind the sun, so you can't see them at this time. Okay, so now if you now notice that the sun, the Earth, and Jupiter are all lined up. Now, they're lined up. They're the closest here that they can get a little bit closer, but not very much closer than they are right now. And if you go out now on a clear night, you will see Jupiter and see that it is really bright. It is because it is so close to the Earth. So, so that's what that's the solar system, and I thank you.